In this lecture, we will learn some advanced functions for three-dimensional joinings, including Boolean operations and two-dimensional conversion functions. First, let's go to see the Boolean operations. Actually, the Boolean operations can help us to draw some very complex three-dimensional objects. In AutoCAD, there are three fundamental Boolean algebra functions: union, subtract, and intersect. Let's go to see the details of these three functions. First, we will consider two cylinders, A and B, and they are intersected with each other. Then for the first function, union, we will have the operation A or B. The result will be on a single object, which will contain both A and B. The second operation is a subtract. The result of A minus B will be the 3D objects caused by the cylinder of A minus the intersect of A and B. Similarly, for B minus A, it would be the cylinder of B minus the intersect of A and B. That's the result of B minus A. And the last one is intersect. So you can use A and B to find out the intersect of these two cylinders. So that's the operation of these three Boolean algebra functions. Now I will show you how to use the three Boolean operations. Here in this example, we assume that the red cylinder is A and the white cylinder is B. And then we can apply the union operation. You can type the command union or go to the 3D tools and find out the union icon. And then click enter. You can then select the cylinder A, cylinder B, and then click enter. It will combine these two cylinders together as one object. And now for the subtract operation, we'll use A minus B. So you can type the subtract, choose A first, click enter, and then choose B. And then you will subtract B from A. And if we want to do the operation of B minus A, similarly, call the subtract command, choose B first, and then minus A. Now you will subtract A from B. At last, we will see the intersect operation. Type the intersect, or you go to the toolbar, choose the intersect icon. And then you just need to choose the A and B cylinders. Click enter, you will find out the intersect of these two cylinders. So that's the way for you to use the three Boolean operations. In this example, I will show you how to use the Boolean operations to complete the four figures here. Now for the first example, it's actually on a pyramid minus a sphere on the top. So to generate this figure, we have to use the subtract command. Choose the pyramid first, and then select the sphere. Now you get the first figure. For the second one, it's similar. You are using the torus minus the box. So use the subtract command, choose the torus, and then choose the box. This is the way for you to get a second figure. For the third one, we have to use the union operation. So go to the union, choose the two cylinders, and now you combine them together as the third figure. For the last one, you still need to call the subtract command, and then choose the cone first, specify the sphere as the second object. And that's the way for you to generate the last figure. Now let's see the two-dimensional conversion functions. Actually, this type of functions can help us to convert 2D objects into three-dimensional objects. The first function we will learn is a polysolid, and the command is just a polysolid. This command can help us to generate a 3D polyline with the same height and thickness. And the segments could be in the arcs or the lines. Also, with this command, we can generate the 3D polyline from a two-dimensional line on a two-dimensional polyline. So in the next demonstration, I'm going to show you how to use the polysolid in AutoCAD. To generate the 3D polyline, you have to call the command polysolid. And then, before you start the drawing of the 3D polyline, we have to specify the height and the width of the polyline. Say the height is 10 units and the width is 1 unit. The justify option here is applied for you to specify the location of your cursor. You can choose the left, center, or the right location for you to identify the polyline on the three-dimensional environment. Now let's choose the center. And then you can start the drawing of the polyline. Here you will see that the thickness of the polyline generated is about 1 unit and the height is about 10 units. You also can generate arcs. The generation of the arcs is the same to the two-dimensional polyline. You can also specify the 3 points to identify a new arc. And if we want to change it back to the line, go to the line option. Also, you can choose a close to connect the last point and the origin. And this is the generation of the polyline under the three-dimensional space. And you can see that this command is very useful for you to generate a wall for the room layout or some similar three-dimensional objects in this kind of design. In addition, the command can also help us to convert two-dimensional lines or the polylines into the 3D polylines. For example, if we have one polyline under this three-dimensional space, you can call the command polysolid and then specify the height and width. Say the height is 5 units and the width is 0.5, and then choose the object. Select the polyline. You will convert this polyline into a 3D polyline. The width is about 0.5 units and the height is about 5 units. So that's the implementation of the 3D polyline in the three-dimensional space. The second two-dimensional conversion function we will learn is extrude. And this function can help us to extrude the two-dimensional object to generate a 3D object. In the example here, we can use the extrude command to extend this two-dimensional plane and generate this three-dimensional solid object. And the cross-section of this 3D object will be exactly the same to this two-dimensional plane. Also, you can extrude a two-dimensional object along the vertical direction, a predefined direction, or along the path. In the next slide, I'm going to show you how to use the extrude command. Now, let me show you how to use the extrude command in AutoCAD. First, we have to call the command extrude. Or you can go to the toolbar, choose the 3D tools, and find out the extrude icon here. And then specify the two-dimensional plane you want to work. And now, click enter. You can start the extrude operation. The default method is to specify the height of the object so that you will extrude the two-dimensional plane under the vertical directions. So the height is 10 units. And now you complete this three-dimensional object. You can also use the extrude command and extrude the two-dimensional objects under a specific direction. Say the direction is start from the point of 0, 0, 0, and the end point is 5, 5, 5. And now it generates a three-dimensional extrude object. The last one is called the path. You can specify the two-dimensional plane and then choose the path option. Specify one path. It could be a line on a polyline on a spline. And then you extrude the object along with the path we just defined. So that's the operation of the extrude. Also, there are some other functions like the table angle expression, we will introduce the details about these two functions when we are talking about the surface of the 3D objects. In this example, I will show you how to use the extrude command and the Boolean operations to complete the three-dimensional objects in this figure. This is the three-dimensional objects in the example. Right now, we view this object with the conceptual style. And if we want to draw this object, we have to change it to the 3D wireframe style. And with this style, we can draw all the objects accurately. And as in this example, we would like to use the extrude command so we can draw the cross-section of the three-dimensional objects under the two-dimensional modeling space. So we can change the viewport back to the top. And then we can go to the two-dimensional toolbars. First, we will draw a circle with a diameter of 12 inches. And then we will draw a smaller circle inside with a diameter of 3 inches. And next step, we will draw an arc, start from one quadrant point here, and end at the center. We specify the angle as 90 degrees. And next step, we will draw a smaller circle here. The radius is 0.25. And we will then call the array command, choose the small circle as the source object, and specify the path. Choose the arc as the path. And now define the base point as the point here. The number of the items should be selected as. So you first go to the method, choose the divide method, and number of the items is choose as 8. And you also have to set the associative as no. Now you complete the generation of the smaller arcs. The next step, remove these 3 circles and the arc. Now call the array command. Choose the 5 circles as the source object and specify the polar array. And the center will be the center of the larger circles, and the item number will be 8. And that's the way for you to generate all the smaller holes inside of these 3D objects. Now we can call the extrude command. Choose all those objects and specify the height as 3 units. And then you can see that it will generate a 3-dimensional object. But here, if we go to the conceptual style, you cannot see the holes. So you have to call the subtract operation. Go back to the two-dimensional wireframe and go back to the two-dimensional working environment and use the subtract command. Select the larger arc as the subject and then choose all these smaller circles inside. Click enter. You complete the Boolean operation of the subtraction. Now let's go to see the conceptual style of this object. You will see all those holes and change to the southeast isometric view. And you can see those holes, a larger hole and a smaller hole. So that's the second example for you to use the extrude command. In this example, I will show you how to use the Boolean operations and the two-dimensional conversion function to complete the wall with the one door and one window in this picture. To complete this design, we shall first use the polysolid to generate the wall. So first, we will switch the style back to the 2D wireframe, and then type the polysolid command. Specify the height as 15 units and the width as 1 unit. Then we can define the wall. Click Enter to complete the generation of the wall. And next step, we will specify the location for the window and the door. So we need to call the user coordination system and choose the face method and define this plane as the face of the new coordinate system, which is the XY plane. And now we will call the box command. Define the location and the shape of the window. Put a very high value for the height. Also, we can do the similar process for the door. Define very large value for the height. And now we can call the subtract command to find out the space for the window and the door. Subtract, specify the wall as the source object, and we will subtract the two boxes. And now you will have the window and leaving a space for the door. At the next step, we will call the user coordinate system again. Specify the method as z-axis. Define this corner as the origin and specify this vertical line as the z direction. And also, we can then call the line command. Start from the midpoint of this short segment. Define a line segment with a length from here to here, which is about 8.4. At 8.4, and angle is 30 degrees. And then we can call the polysolid command again. Specify the height. The height will be the length of this line segment, so you can choose one point here and another point here to define the height. The width is still set as 1 unit. And then choose the object. We will choose this line. Now it will generate a 3D polysolid line. And this one will be used as the door. Now if we go back to the conceptual style, you will see that it will generate a window here and a new door here. That's all about the third part of the three-dimensional drawings. In this lecture, we learned some Boolean operation functions and two-dimensional conversion functions. And those functions are very useful for us to draw complex three-dimensional objects. So after class, you can follow the instruction in this video and complete the examples by yourself.